Hello viewers, good day to you all. You're welcome to today's class. I remain your pro guide for chemistry, Aisha Bandi. The video is sponsored by Proch Connects. Today we are going to look at a topic which is called the freezing point depression. So we are going to look at the definition of the topic, its importance and some of its real life application. We are also going to look at the mathematical formula for the freezing point depression. Then we solve some mathematical problems under the topic. Freezing point depression is a crucial concept in both theoretical and practical chemistry, which influences both industries and also in carrying out scientific research. The freezing point depression has to do with solutes and also solvents. The freezing point depression, it has to do with the presence of a non-volatile solute in a solvent to form a solution which disrupts the orderly state of matter. So that's what freezing point depression is all about. So the freezing point depression, in summary, is the freezing point of solvent minus freezing point of solution. So in summary, this is just what the freezing point depression is all about. Some of the importance or the real life application of the freezing point. The freezing point depression is used in the determination of molar masses of different compounds. It is used in food industry for purity analysis. It is used in practical application for antifreeze and de-icing. So these are some of the few applications of the freezing point depression in real life. So now let's move on to the next one we have, which is the mathematical formula. It's important for us to know that the magnitude of the freezing point depression is directly proportional to the number of solid particles dissolved in solvent. So let's go to what we have next, which is the mathematical formula for the freezing point depression. The mathematical formula for freezing point is giving us change in Tf. This is freezing point depression. So this is giving equal to IKF times M. Okay, so each of these letters here have their meaning. The I stands for Van Hoff factor, which usually is equals to 1. Okay, so the Kf here is the constant, that is the freezing point depression constant. That's what the Kf stands for. So this is a constant. Then we have M. M means molality. Okay, this is molality. So there are some other formulas we need to know under this. We need to know that formula for molality is equal to moles of solutes divided by mass of solvent. So this is the formula for molality. So these are some of the few formulas we need to know under the freezing point depression. We also have a relation that says that the freezing point depression is equal to TSE minus TSO, where TSE is greater than TSO. This is the temperature of the solutes and this is the temperature of the solvent. So with this now we can move on to the mathematical questions we have. The first question says we should determine the freezing point of a solution of 60 grams of glucose, which is C6H12O6, dissolved in 80 grams of water. So we are given the freezing point of water to be minus 1.86 degrees Celsius per mole, while the molar mass of glucose has been given as 180.2. Looking at this, we are to look for the freezing point of the solution, the T, that is the change in TF. So this is what we are looking for in this question, which is change in TF. Okay, so this is our unknown. So they said of a solution of 60 grams of glucose. So we are given the mass of glucose as 60 grams, and this glucose is a solvent. Okay, so this is also known as the mass of the solvent. So moving on, and we are told that it's dissolved in 80 grams of water. So this is the solution. Water is the solution here. So the mass of water is given as 80 grams, and this is the solution. Okay, and we have the freezing point of water, that's Kf of water, given as minus 1.86 degrees Celsius per mole. And the last parameters we have is the molar mass of glucose. Okay, so the molar mass of glucose is given as 180.2. So the first thing we need to find in this question is the number of moles of glucose. Okay, so step one, we have to find the number of moles of glucose. And for us to find the number of moles of glucose, we're going to use the relation, which is the mass of glucose all divided by the molar mass of glucose. Okay, and all of these parameters has been provided from the question. So the mass of glucose is given as 60 over the molar mass of glucose has been given as 180.2. So punching our calculator, 60 divided by 180.2, and this gives us a value of 0.333. So this is the number of moles of glucose. Okay, so the next step is for us to find the mass of solvent, which is water in kilograms. Okay, so for us to get the mass of solvent, as you can see, the mass of solvent has been given. The solvent here is the water, right? But we have to find it in kilograms because we have been given here in grams. So this is equals to 80 grams. And for us to convert 80 grams to kilogram, we divide by 1000. 80 divided by 1000 gives us 0.08 kilograms. Okay, so here we have 0.08 kilograms. Okay, now the next step is for us to find the value of M, which is the molality. Remember the formula is change in TF is equals to IKF times M. Okay, so now for us to get the molality, so now we have to find the molality of the solvent, okay, which is what? The water. So remember I stated that the formula for molality, mass of the solute divided by the mass of the solvent. So this is equals to, now the mass of the solutes, okay, all over the mass of solvent. So all we need to do now is substitute in. So we have our mass of solutes, which is the number of moles of glucose, which we've calculated to be 0.333, all divided by the mass of the solvent, which we have calculated as 0.08. So from here, all we need to do is to punch the calculator 0.333 divided by 0.08, and this gives a value of 4.1625. So here we have equal to 4.1625. So now we have all the relations we need. Okay, we have the relations we need for us to get the freezing points of the solution. So now using this relation, so change in CF is equal to, our I here is going to be 1, okay, times the KF, which has been given, there's a KF of water, which has been provided from this question as minus 1.86, right? Times, now, the molality, which we have calculated to be 4.1625. So all we need to do here is to punch our calculator. 1 times 1.86 times 4.1625 gives us a value of minus 7.74. So this is the temperature, that is the freezing point of the solution, which is the freezing point of water. So remember, I stated earlier that we have that the TSE must be greater than the TSO, where the TSE is the temperature of the solvent and TSO is the temperature of the solution. So the temperature of solution here is minus 7.74. Okay, so and the temperature of the solvent in this case, that is our TSE in this question, is equals to 0 degrees Celsius. And we can see that 0 degrees Celsius is greater than this, right? So 0 degrees Celsius is greater than minus 7.74. So this shows that our answer is correct, okay? So let's move on to the next question.